redox basic. What is a redox reaction? A redox reaction is any chemical process where electrons move from one species to another. It's a pair electron transfer event where one substance loses one electron, which is oxidation, and another gains them, which is reduction. Remember, oxidation is a loss of electron and reduction is a gain of electron. Rules for assigning oxidation number. First, element and ions. Pure element have oxidation number equal to 0. Monoatomic have oxidation number equals to their chain. Second, sum rule. Sum of oxidation number in the compound is 0. Third, oxidation. Usually -2, except in peroxide, which is -1. And next, hydrogen. Usually +1 with non-metal. And the last one is halogens, usually -1 with metal. And quick number check. Find the oxidation number. First, sodium carbonate. Carbon is +4. Second, permanganate ion. Manganese is +7. And the last one is hydrogen carbonate, which is hydrogen is +1. Practice confirm mastery. This example verified the bookkeeping method for tracking electron movement.
Part 2. Agents and transfer. First, oxidizing versus reducing agents. Oxidizing agents, the species that accept electrons, which is the electrons acceptor, and it gets reduced. Second, we have reducing agents, the species that donates electrons, which is the electrons donor, so it gets oxidized. Remember, the agent's role is opposite to its own change. It causes the change in the other species. Two ways to spot redox. First, by electron transfer. Second, by oxygen transfer. First, by electron transfer is oxidation with loss of electrons. Moreover, reduction will gain of electrons. Next, we have by oxygen transfer. Oxidation will gain of oxygens, then reduction will loss of oxygens. So, both viewpoints identify the same redox couple and help spot agents quickly. And lastly, we move to the third view, which is hydrogen transfer. This perspective is useful in organic and biochemical redox. The rule is simple. First, loss of hydrogen is oxidation, while gain of hydrogen is reductions. For example, ethanol is converted to acetaldehyde by using hydrogen, which is an oxidation reaction.
Part 3 is about balancing redox reaction. The first step is to split the equation into half reaction. Next, we balance the atom and the charge into each half reaction. After that, we equalize the electron, then we add the two half reaction together. Key principle: all electrons lost in oxidation must be gained in reduction. Use H2O and H to balance oxygen and hydrogen in acidic solution. This is an example of balancing a redox reaction in an acidic medium. The reaction involves dichromate ions reacting with iodide ions to produce chromium ion iodide. Balancing a redox reaction in basic medium. After the equation is balanced in acidic condition, hydrogen ions are still present in the equation. To change the reaction into basic condition, hydroxide ions are added to both sides of the equation to neutralize the hydrogen ion. Each hydrogen ion reacts with a hydroxide ion to form water. If there are extra water molecules on both sides, they are cancelled out. The final equation represents a redox reaction balanced in a basic medium.
So, for part 4 is about key takeaway and the summary of all the chapter 4 that we learned through our other members before. So, for summary for chapter 4, that is, redox is actually electron transfer. When the atom loses an electron or gain an oxygen or hydrogen, that atom undergoes oxidation reaction. Meanwhile, the opposite thing that happened to atom, such as gain electron and gain oxygen, they will undergo reduction reaction.
For balancing reaction,
A thing that we need to remember. First, split into half fraction. We need to remember how to split the equation into half fraction, then how to balance atom and charge, if it include polyatomic or ions, and third, we need to know how to equalize electrons and add half together. Four, you need to remember that base is actually has OH ataupun hydroxide on the equation. If we need to neutralize it, we need to plus H so that it will become neutralized. And lastly, we need to know how to verify mass and charge balance so that we know how to write the equation and balance the polyatomic ion.